Hello guys, so today we're going to discuss a question that is about recursion, right? We're going to calculate the recursion tree, how we can calculate the time complexity of the code and the space complexity. And majorly we will see the recursion tree itself. So let's see what code is that. The question is of the course I'm doing, that is of Learnyard, right? That is of Learnyard, this one. So this course I'm doing, and from here the articles are very good. You can buy the course from Mohammed Faraz. His YouTube channel is there. From there you can buy the course for complete DSA, right? So let's get back to into the question, the complexity analysis, right? So what is the question? The question is of finding exponential of a number, right? So we can do it by recursive calls, right? We can do it using recursive calls, and that is by uh, doing creating a partial answer and storing it and calling the function with a recursion, right? And then we can do it. But here we are going to see how a small change in the code can uh, determine a very large thing in the recursive tree. So this is a code. This is one of type of code that is optimized, that is good, that is right. But while learning the recursion and while analyzing the time and space complexity of a recursive function or recursive calls, we have this code, the same, that does the same thing here, right? So the code is this one, this code. So this code is slightly bit different from this one. You can see that I have stored the in a variable partial answer and call the recursion with values, right? So there, and then I am squaring it up, the partial answer itself. But here in the other case, what we are doing, that I am creating a partial answer, that's fine, but I'm not doing like this, that I am multiplying the partial answer itself. What I'm doing, that I'm calling the recursion two times. I'm calling the recursion two times, right? One with x and n by 2, another is x and n by 2. So this seems pretty insignificant, right? So no, but that is not insignificant, that is significant. This slight change can in the code can make our recursive call and time complexity, can affect it in a huge way. So let's see what this means, right? So first I will show you the recursion tree of this this code and this code. What is the difference if we calculate those two things? So the recursion tree is, I'm gonna copy it from here, and that's the mermaid compiler. Create you can create So this is the recursion tree of the first code, that was this one, right? So this is the first code. So here we can see that there is a power helper, that is the parent function, right? Which will call all other functions. Okay, so I'm gonna do one thing. I'm going to just let's see. So here we have the function, right, which will call. And how will it call? First the parent function will gonna call this one, which is my power helper 2 3. So it will recursively call itself with this. First it will tackle the left ones, as we know recursion does, and then it will go to the right one to exponentiate the number. Okay, so first it will go to the, it will split its power of 2 3, right? It will split it, and what it will do, it will split it into two halves, right? It will split it into two halves. It will split it into two halves. First is this and second is this one. Then it will split the left one also. First it will only do the left half, so we're not gonna look into the right half yet, but it will gonna do the left half first. So this one it will do, and this function will also call the left one first. So left one will be 2 and 1. It will be, the half will be go to 2 and 3, and its half, that is 2 and 1, right? So it will then call this function, and then it will gonna call this one. Then it will return it back 1.0, right? When it is, when the mm when the base case was what? The base case was, the base case was if n is equal to 0, right? If n is equal to 0, return return 1 1 1 year value, double value. So it will return 1 to this one. Then what will gonna do? It will gonna return this one to this, right? It will gonna return, it will gonna return this to this. Then again it will gonna call, it will gonna call this one. It will gonna call and will gonna then return this one again. Then it will gonna return this. Then after that 2 3 will gonna call again. It will gonna call this one. Then it will return, this one will return it, like that. Then my helper will return all of these things to the main function, which call them all. Then the main function will do its right work. Its right work will be this. It's gonna call this, right? And it will gonna return the same thing. So lastly we're gonna have 128 here, right? And here it will gonna all do stuffs. So 128 we're gonna have, and it is pretty simple. Okay, but let's see what it changes when we